talk about test case design techniques. So if you are a manual tester, if you are testing a project, so you need to write test cases. So your test cases should cover different scenarios like valid, invalid, and error conditions, right? So you can write test cases based on your knowledge and experience. But if you follow certain test case designs, your test coverage will be more, and you will be able to cover different functionality using these test case design techniques. So I will show you what are these different test case design techniques and how to use them in your test cases. So please subscribe to my channel QATutorials to know about latest tutorials I upload in this channel, and click on bell icon to get notifications whenever I post new videos. Okay, let's get started and see what are these different test case design techniques. So these are the different test case design techniques for a better test case writing, right? There are 5 techniques we're going to discuss today. So one is boundary value analysis, another is equivalence class partitioning, then decision table based testing, state transition, and error guessing, right? If you follow these techniques, so you should be able to write better test cases, and your functional testing coverage will be high. So let's look into each of these techniques one by one. So what is boundary value analysis? So this is very simple technique which will ensure that you are covering the values between around the boundaries. Like, so most of the time in the testing, the errors happen around the boundaries. That's why this technique is developed, to make sure you are testing the boundaries of different values. So that is why it is called boundary value analysis. So basically, boundary value analysis is based on testing at the boundaries between partitions, right? It includes maximum, minimum, inside or outside boundaries, typical values, and error values, right? So it basically includes the maximum value, minimum value, and inside and outside the boundaries, right? So let's see some example. Suppose there is a function that accepts a number between 18 to 30, right? So where 18 is the minimum and 30 is the maximum value of a valid partition, right? So basically the values, accepted values, are between 18 to 30, right? So if you say accepted values are 18 to 30, so all these values like 19, 20, 21, 22 to 29 are all valid values, right? So that is a valid partition, right? So what is the minimum value of this partition is 18, maximum value of this partition is 30, right? So you'll have 2 test cases for that. But based on this boundary value analysis, we're going to write some test cases for invalid partition, right? So which is invalid partition, right? One which is less than 18 is one invalid partition, such as 12, 14, 15, 16, and 17. And more than 30 is also another invalid partition, like 31, 32, 34, 36, and 40. So when you are selecting test cases, we're going to select one valid value, another invalid value which is less than 18, another invalid value which is greater than 30. Right? That way, we are capturing the valid and invalid partitions, see how the system behaves, and we're going to write test cases for these valid and invalid partitions. So whenever you see like a range, or it accepts certain number of characters or a certain number of digits, a range, a valid value like true or false, we're going to do this boundary value analysis, right? This is one technique to develop test cases. The next one is equivalent partition. So equivalent partition is basically allows you to divide set of test conditions into a partition which should be considered same, right? We want to divide the test conditions into multiple partitions. So if you take one value from each partition, it is as we can assume that we tested that full partition, right? There is three sets. If you take one value from each set, it is equivalent to testing the whole set. So that is the meaning of equivalence class partition. So this software testing method divides the input domain of a program into classes of data from which test cases should be designed. Let's look at how to do this, right? So this is the guidelines for equivalence partitioning. Suppose if you have a range condition, say in the previous example we said like we can take valid values from 18 to 30, then we need to take one valid and two invalid equivalence classes defined, right? So one valid value and two invalid values will come because it is a range. Invalid value can be below the range and above the range, right? So suppose if you give a specific value and one valid and two invalid values are given. Suppose you say like only you take input as a valid value as 10, then valid value is 10 and invalid is less than 10 and greater than 10. So there are two invalid values. So if a member of a set is given as input, suppose if we are testing a member of a set, so then one valid and one invalid. So like one inside the member, another outside the member of the set, right? So there's two scenarios, right? Suppose if you get a Boolean number, then one valid and one invalid. Suppose you always take true, then there is a false is the invalid class, true is a valid class, right? These are the guidelines of equivalence partitioning, right? You are basically testing from valid partitions and invalid partitions in your test cases. That way your test coverage will be good. Let's see some real-time example. Suppose we are getting these 6-digit OTP numbers normally in your mobiles when you do banking and all that. So whenever you enter less than 6 is invalid and anything greater than 6 is also invalid, right? So basically you have one valid partition where you take all 6 digits, that's a valid partition. Anything less than 6 is an invalid partition, anything above 6 is also an invalid partition. So that is one valid partition and two invalid partitions in this case, right? So if password is entered by user is less or more than 6 characters, that equivalence partition method will show an invalid OTP. If password is exactly entered as 6 characters, then equivalence partitioning method will be show valid OTP. So here like two invalid and one valid partitions are there. So let's see how this looks. So here if you see, right, so the invalid digits greater than 7 is invalid, digits less than or equal to 5 is also invalid, digits equal to 6 is the valid partition, right? So you need to have test cases to covering all these three partitions, two invalid and one valid partition. So this is how equivalence partition works. So this basically it simplifies your test case design if you follow these techniques, right? So this is the equivalence partition. Then decision table based testing. This is another technique that is used in test case designing. Is a decision table. It's also called as cause effect table also. This software testing is used for functions which respond to a combination of inputs or events, right? So there will be certain number of inputs for a specified output. So that time a decision table is used. For example, submit button should be enabled if user has entered all required fields. Suppose you are testing a form, your submit button is only enabled when all the required fields are inputted, right? So if you have 2 to 3 fields like first name, last name and email, so you want user to enter first name, last name, email before you enable the submit button. So this is kind of a decision table. If any of those fields are not entered, submit button will not be enabled, right? So it's the input cause and effect, right? If we don't enter, it will be enabled. So what are the steps? So basically, this is how you create a decision table. Enlist all inputs in rows, right? You're going to put all inputs in rows, enter all the rules in the columns, right? In the rows, you have the inputs, and the rules will be columns. So fill table with the different combination of inputs, right? So suppose if you have first name, last name, email, you can say like first name entered, last name not entered, or first name entered, last name entered, but email not entered, like that. So in like that, enter different combinations. So in the last row, note down the output against the input combination. The last row will show you the actual output based on the input combination. So let's see some example how this decision table works. Right here, we'll say like somebody is withdrawing cash, right? So customer requests a cash withdrawal. So one of the business rules for ATM is that ATM machine pays out the amount if the customer has sufficient funds. So if the customer has sufficient funds, it will take the amount from the account and pays it, or if the credit has granted, right? If the customer has a credit grant, then it can allow you to withdraw, right? There are two scenarios. And so even though this is a simple example, it's complicated to describe in text. Like if you're writing like in scenario wise, it gets complicated. So that way the decision table makes it easy to write your scenarios, right? So you can make a decision table, as we mentioned, like inputs are rows, right? So inputs are basically withdrawal amount less than or equal to balance, credit granted, and withdrawal granted. The action is, the output is basically withdrawal is done, right? Withdrawal is granted. And what are the rules? Rules 1, 2, 3, right? So this is say withdrawal amount less than balance, right? So this is true. That means there is enough balance to withdraw the amount. Right? Then what is the output? So you don't need to worry about credit granted because available balance is there, the output is true, right? Suppose in the second scenario, the amount is less than the amount, but there is a credit granted is true, then you can still withdraw the money, right? So in the rule 3, if both are false, you cannot withdraw money, so this will become false, right? So we're going to write 3 scenarios here. One, withdrawal amount is less than balance, another is withdrawal amount less than balance, but credit is granted, and another is both are not available, it becomes a false, right? So you can see these scenarios, test case for R1, test case for R2, test case for R3. At the last one, there is no credit, you're going to get no withdrawal, denied. So that way, your test cases will be more clear when you create these decision tables. So whenever there you see like multiple inputs and one output, making a decision table and creating scenarios from decision table is easy instead of writing text, long text and things like that. Right, so this is the decision table technique, right? So then another technique is called state transition, right? What is state transition? Basically, it changes, state transition technique changes in input conditions, change the state of the application under test, right? So if there is certain input conditions, it will change the application under test, like it will change the state of the application. Just like say if you go in the ATM, you're going to enter your PIN number. So if you enter PIN number like 3 times, right, wrong PIN number 3 times, the application gets locked, right? Basically based on your input conditions, so the application behavior is changed, right? That is called as change of behavior of application under test. That is basically state of the application, right? So this the tester can perform this action by entering various input conditions in a sequence. So in state transition technique, the testing team provides positive as well as negative input values for evaluating system behavior. So we're going to provide positive values as well as negative values to test how the system works using state transition. So these are basically the technique to increase the coverage, right? These are all the different techniques. So state transition should be used when a testing team is testing the application for a limited set of input values, right? This technique should be used when testing team wants to test sequence of events which happen in the application under test, right? So in the decision table technique, there is only one output, but here, based on the input, so the application changes, right? The state of the application changes. There is the multiple states in the application. That's where you use the state transition. Here is an example of that state transition. When you try to enter like incorrect pin like 3 times, the account gets blocked. But if you enter like first try or second try, first try if you enter correct pin, you get access. Second try if you enter correct pin, you get access. Third try if you enter incorrect pin, you get blocked, right? This is kind of a state transition. Like, so when you're going for second try, the application remembers that you already entered once, right? When you go for third try, the application remembers that you entered twice already the pin number. So this is a state, right? So the application, what state it is the first try, whether the application is in the first try of the pin number or second try of the pin number or third try of the pin number, the output changes. That's why it's called as state transition, right? So this is how it is, right? First attempt, second attempt, third attempt, access granted, account black. So this has become like a state transition table. There's more states, right? Which state is the application is in, right? So this is how it is. Then I have this error guessing. So this is the last technique, is called error guessing. This is a software testing technique based on guessing the error which can prevail in the code. So this is basically heavily based on the experience, where test analysts use their experience to guess the problematic part of the testing application. So this is more for experienced tester who has domain knowledge and can guess where the application has errors and where the problems will come out. So based on that, this technique is done. So this is basically somebody who has experience and somebody who has knowledge of the domain, right? So to design test cases based on this software testing technique, analysts can use the past experiences to identify the conditions. So this is error guessing technique. So these are the 5 different testing techniques that is used to design test cases for programs. Right, let me show you the summary. So this is a summary. So these are the 5 testing techniques to design test cases. So if you have any questions on these techniques, please put it in the comment section. I will reply to your questions, and please subscribe to my channel QATutorials to view latest videos I post, and click on bell icon to get notifications when I post new videos.